Hi, today we are going to talk about improper integrals. So improper integrals are definite integrals where one of the limits is going to be infinity or possibly both, or they're both finite, but one of them or both could be at the location of a vertical asymptote. In other words, where the function is not going to be defined. So when you evaluate improper integrals, you will have to use limits. So let's take a look at this first example. We have an integral going from 1 to infinity of 3 over x cubed. So we have infinity as one of the limits. And what I typically do is I rewrite that. So this is the one where there's no issue with 1. But infinity here is not acceptable as a value. So we're going to rewrite that as the limit. As some value a approaches infinity. And then we're going to have an integral from 1 to a of 3 over x cubed dx. Okay, so now we're just going to go ahead and work on the integral. We're going to keep the limit there. So it's the limit as a approaches infinity. The integral here is going to be negative 3 over 2x squared. You can check this. And this is a definite integral, so we're going to evaluate it from 1 to a. We're going to substitute 1 and a into that, following the regular rules for definite integrals. So that's going to give us negative 3 over 2a squared plus 3 over 2. And now we're going to use limits. So the limit of a constant is going to be that number. What happens here? When infinity goes here, this whole thing is going to become effectively 0, right? Because we're dividing by a very large number. And the answer is going to be 3/2. Okay, so this integral converges. It does give us a finite value. Okay, next problem. Integral from 1 to infinity of 4 over cube root of x. Same problem, one of the limits is infinity, and we're going to use a limit expression there. So limit is some a approaches infinity of the integral from 1 to a of, let me rewrite that as 4 times x to the power negative 1/3 to make it easier for integration. So we got that. We're going to have the limit as a approaches infinity. So when you integrate this, it's going to give you 4 times x to the power 2/3 divided by 2/3 from 1 to a, which will give us, once we simplify this complex fraction, that's going to give us 6x to the power 2/3 from 1 to a. So we can substitute the values now. It's the limit as a approaches infinity of 6a to the power 2/3 minus 6. And what happens here? This goes to infinity and this is going to go to infinity. This 6 is not going to matter, so it goes to infinity. This integral diverges, which means we do not have a finite value. Okay, we don't have a finite value, you can't have an answer here. Next problem. Have this integral. We'll go from 0 to infinity. 0, no issue. Infinity, a problem. It's not a defined value. So we're going to rewrite it as the limit that as a approaches to infinity of integral from 0 to a of 3x squared e to the negative x dx. So over here I'm going to use, it's one of these problems where you have to use either integration by parts, which is going to take forever because you're going to have to do it 3 times, or we're just going to do a tabular method, which I have another video explaining that. So we're going to have 3x squared here, and here is going to be e to the negative x. So here we differentiate, this will eventually become 0, 6x, 6 and 0, and here we're going to have negative e to the negative x, e to the negative x, negative e to the negative x, And then we're gonna go ahead and, oops, my apologies, going this way, plus, minus, plus, minus. So after that we can set it up with the whole thing. It's going to be a little bit busy at first. So now this integral here, when you do it, so it's going to be the limit as a approaches infinity. We are going to get negative 3x squared e to the negative x minus 6x e to the negative x minus 6 e to the negative x, going from 0 to a. Now we substitute, so that's going to give us the limit as a approaches infinity. So we substitute a, and I'm going to rewrite it a little bit differently when the negative exponents are on the bottom. There's going to be negative 3a squared over e to the a minus 6a over e to the a minus 6 over e to the a, and then minus, so that's for the first part when you substitute a, and then you substitute here, this is going to be 0 minus 0 minus 6. So we know, hopefully by now, that an exponential function is always going to outpace any kind of a power function. So every single one of these integrals, every single one of these fractions with a going to infinity is going to be 0. And this is 0, and the whole thing is going to equal 6. Okay. Moving on. So this is an integral from negative infinity to positive infinity of 3 over 9 plus x squared. So with this one, we have infinity for both of them, and we're going to have to use two limits, and then we're going to have to split this integral somewhere. I usually recommend splitting it as 0 as long as there is no issue. With 0 there is none. So what we're going to have here is the limit as a approaches negative infinity of the integral from a to 0 of 3 over 9 plus x squared dx, plus, and then we're going to have another limit where some value b approaches positive infinity, the upper limit of the integral from 0 to b of 3 over 9 plus x squared dx. So now that we got both of them with limits, we can go ahead and find the antiderivative. My apologies. Find the antiderivative, which is actually arctan of x over 3. So what we have here is the limit as a approaches to negative infinity of arctan x over 3, going from a to 0, plus the limit. Next one is also arctan, right? So just b goes to infinity, and this one is going to be arctangent x over 3 going from 0 to b. So we're going to have the limit as a approaches negative infinity of arctangent 0 minus arctangent a over 3 plus the limit as b approaches infinity of arctangent b over 3 minus arctangent 0. Okay, so even though we go to negative infinity, arctangent is going to approach pi over 2 in one case and negative pi over 2 in the other case. Arctangent of 0 is pi over 2 when you go to negative infinity, and actually it's negative pi over 2 when we go to, so, well, arctangent 0 is 0. Arctangent of in negative infinity is going to be negative pi over 2, so it's going to give you positive pi over 2. And then plus, and this here is going to give you negative pi over 2. So it's going to become positive pi over 2, and then the whole thing is going to equal pi. Okay, moving on. This one here. So this one requires for you to use U-substitution, and it's also improper. So the first thing we are going to do is rewrite that with limits. So the limit as a approaches infinity of the integral from 0 to a of 1 over e to the x plus e to the negative x dx. So what we're going to have to do is we're going to have to set up e to the x as u. So then e to the x dx is going to be du. We are going to multiply the top and the bottom by e to the power x. Let me indicate this here. We're doing that to get rid of that negative exponent. Just one of the methods we can use here for integrating. So it's the limit as a approaches infinity of, what do we have here? We're going to end up getting the integral from 0 to a of e to the x divided by e to the power 2x plus 1 dx. So now this u substitution here that I used, I'm going to actually do it. So this is going to give me the limit as a approaches infinity of the integral. After the substitution here, I'm going to have 1 over 1 plus u squared. One thing that we do have to keep in mind is because this limit was 0, but we go into a different variable, you have to plug in this 0 in this function, so the lower limit is going to change to 1. The upper limit will still remain infinity, so that's, you know, when you plug an infinity into this function, it's still infinity. Okay, du, that is going to give us the limit as a approaches infinity of arctangent u going from 1 to a. So it's going to give us the limit as a approaches infinity of arctangent a minus arctangent 1. So arctangent a, that's arctangent infinity, this is pi over 2. Arctangent 1 is pi over 4. And it's going to give us pi over 4. Okay, next problem. So what happens here, we don't have infinity as a limit. So what is the problem here? The problem here is 0. So when we approach 0, the natural log of x is not defined. So we can approach 0 from the right hand side, but we can't actually use 0. That's what makes this integral improper. That's one of the things that students sometimes overlook. It's the limit as a approaches 0 from the right of the integral from a to 1 of x ln x dx. So what we do here is we are going to use a tabular method just to make things easier. So ln x goes here, x goes here, so differentiate this, that's 1 over x, integrate this, it's x squared over 2. We do not get 0, but that's going to work for us this way. So we're going to go this way, and this is going to be plus, and this is going to be minus, right? So this ends up being limit as a approaches 0 from the right of x squared over 2 ln x minus the integral of x over 2 dx. The integral is still going to go from a to 1. So this whole thing is going to end up giving us the limit as a approaches 0 from the right of x squared over 2 ln x minus x squared over 4. So we substitute this. It's going to give us the limit as a approaches 0 from the right. So what are we getting here? We're going to get 1/2 ln 1 minus 1/4, and then minus a squared over 2 ln a minus a squared over 4. Let's see, natural log of 1 is 0, so this whole term is going to be 0. So here, when a goes to infinity, this term here is going to be 0. This we can't do because it's an indeterminate form. It's 1 times infinity. But that actually turns out, after you do everything, this is going to go to infinity, this expression here. And this whole thing is going to end up giving you negative infinity, and this one is going to diverge. Okay. Okay, this one. So we have limit of integral of tangent from 0 to pi over 2. I do want to remind you, pi over 2 is not defined. Tangent of x is undefined at pi over 2. So since we're approaching from 0 to pi over 2, we're going to approach pi over 2 from the left. There's actually a vertical asymptote there. So we have the limit as a approaches pi over 2 from the left of the integral from 0 to a of tangent theta d theta equals. So what we can do now is we can actually integrate that. That's a pretty standard integral. So it's the limit as a approaches pi over 2 from the left. This is going to be ln of the absolute value of cosine theta from 0 to a. Right, so it's going to give us the limit as a approaches pi over 2 from the left of ln of cosine a minus ln of cosine 0. I don't need the absolute value anymore because I'm actually I don't have any negative values for theta, so it's not going to be, and that cosine is going to be positive theta. But cosine of 0 is 1, but ln of that is going to be, cosine of 0 is 1, and ln is going to give you 0. So this term is giving you 0, because ln of 1 is 0. But what about the other one? So as cosine goes to pi over 2 from the left, the value of cosine is going to approach 0, and then the value of ln is going to approach infinity or negative infinity, whichever way, so it's going to be undefined. This one's going to diverge because of that. So again, cosine here, when you substitute, when you get closer to pi over 2 from the left, this value is going to approach 0 from the so what we have. So as this happens, cosine A is going to approach 0 from the right, which means ln of cosine A is going to approach negative infinity. Okay, and that's not going to work, so undefined. Okay, I think we got one more problem. So we have this limit. It looks a little, well, hopefully it doesn't look scary. But where is the issue here? Why is this one improper? This one's improper because at 6, the bottom is going to be 0. And since it's 0, that's not going to be possible to just substitute that, and we're going to have to use the limit. So we're going to have to use the limit. As a approaches, now we go from 3 to 6, so we're going to approach 0 from the left, so 6 from the left of this integral from 3 to a of 1 over 36 minus x square root dx. Hopefully you recognize it. This is arc sine, so it's going to be the limit as a approaches 6 from the left. It's arc sine of x over 6. I'm going from 3 to a, which is going to give us a limit as a approaches 6 from the left, this is going to be arc sine a over 6 minus arc sine 3 over 6. So let's see, as 6 goes to 1, now we have 1 over 1, so this is actually going to approach arc sine 1, which is going to be pi over 2. And then this one's going to be pi over 6, that's arc sine 1/2. And the whole thing is going to give you pi over 3. This is the answer here. Okay, this is how it's done, and I hope this helps.